All right, so this is a course that I have sort of mapped out here, and I tried different versions of the class of this course. I started thinking, well, we're going to just cover OpenGL, we're going to do WebGL directly, and I thought, now we'll just do C programming and SDL, and it's kept shifting it all around. I finally converged on this. Let's use the phaser library. It's not overly demanding. You know, we all have lots of courses to take, and we only have 10 weeks to work in. And the one language that's just really important these days is JavaScript. You see it everywhere practically. It's just almost everybody benefits by learning JavaScript. So that was my main rationale to sort of pick this direction. So to work with Phaser, you have to learn JavaScript. So that's one benefit. Whether you're going to get into gaming or use Phaser later on, it doesn't matter, but you're likely to hit JavaScript at some point. And, well, thank God I took that game development class. So that's that one. Here's my rationale there. There's some articles about how to make money off of web games. I thought these articles were pretty interesting. You know, it's a very small niche market. You know, but there is a way, there's a mechanism to generate revenue from games that are made with Phaser and other games that basically they call them HTML5 games, you know, games that run in the browsers. You know, it's hard. I think the problem is the browsers are all very different, and there's very bad support for sound, by the way, in browsers, but that's coming along. And with this WebGL, that's really opened up a lot of possibilities for browsers. But then there's a problem of user input, like the mouse, touch screen, there's so many different devices. The kind of games that you're going to build are going to be, I think, pretty simple. If they're going to be used across all the devices, they have to be really simple, like single touch, very simple actions, very simple interactions. So I think that's still kind of an open problem, what you can really use. This is a grand sort of way to build something that runs everywhere. Well, what are you going to build that runs everywhere? Because things in the everywhere look so different. You know, the tiny screens, big TV screens, and different kinds of user input techniques. So what can really run in that context? You know, so I think ultimately it's you can't do a lot. You know, that's sort of a conclusion I've come to actually only recently, although it sounds pretty straightforward and simple to understand. But when you have access to everything, and when you publish through browsers, when you publish as sort of a web page, you really can reach all devices. But what do you do when you can reach all devices? Well, you're not going to be able to make you know, Team Fortress 2. You know, you can't play Team Fortress 2 on your phone, right? So it sort of narrows things down. I don't know, what can you make? I mean, Flappy Bird, I think you can run Flappy Bird everywhere.
Yeah, those people who created like Flappy Bird, I think like less than 30 lines of code with Phaser, 30 or 40 lines of code.
Yeah, I saw that. Andrew Brinker did some experiments on that.
Yeah, and a lot of it I've noticed is just mostly a randomizer function to create the pipes and stuff. Place in different areas.
Just enough coding to make everyone frustrated. It's a really frustrating game, isn't it? So anyway, that's that introduction there. Set up Git. I think most people have done this already. If you're going to use Git, so you know, submit your work to me as you go through these things. You don't have to do this, by the way. You know, if you're working on Unreal or Unity, or you know, that's just This is just optional. If you're doing nothing else, then if you want to do the structured approach, then do this. This is the normal course. And then clone the remote repo. I'll send you a clone command. So these are easy. Those 3 steps are easy to finish, or 4 steps. And then there's these JavaScript tutorials. If you know JavaScript already, you can skip these. But if you don't know JavaScript, students have told me that this has been useful to them. I'm always tempted to remove them and just put a link to this MDN, the Mozilla Development Network. You know, they have an excellent resource on JavaScript. I mean, that's the go-to place for JavaScript documentation, MDN, the Mozilla Development Network. But students keep telling me that, oh no, these things can be a little buggy. Sometimes they don't work right, and you're stuck on a lesson. You can't complete the lesson. And I'm ready to axe them all the time, but the students tell me, no, 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 keep them in there. I really, even with the bugs, they were useful to me. So there they are. Use them if you need to get up to speed on JavaScript. And readability. This is a readability assignment. And this is something that most students really need to work on, is how to format your code so that it's readable, optimally readable by others. And this is code that's not readable, so this is something you have to fix this thing. And then there's a programming problem in there, I think, somewhere. Yeah, here's another programming problem. But here's the criteria that I put together for readability. And this is my view of it. And there's other criteria I want to take into account probably. Cleanliness. Do you have a line or more of code in your program that does nothing? You just never deleted it, from a way. That makes your program very hard to read. So I see, int x equals 3. All right, I go, okay, well, where's he using x? And I'll spend the next hour reading the code and say, well, he doesn't use x anywhere. And I had to waste the mental energy to make a note of x and wait to find out what x was being used for. So you got to take out garbage that's left over from the past. Consistent brackets, those are the curly brackets. Those have to be laid out consistently. Do you put them on the next line or on the first line, that sort of thing. Logical indentation, that's, most of you have this already, but a lot of you are a little bit lax about being careful with this. So logical indentation, mainly indentation, shows the relationship of substatements to their parent and closing statements. That's what indentation is. Indentation means is a parent-child relationship. All right. Consistent, you've got to, if you're going to indent, with tabs in one line and it goes next line, you indent with spaces, that's not going to work. Because maybe in your IDE, your tabs are set at 4 spaces, but in my IDE, it's set at 8 spaces. So everything's going to be off. So that means you're requiring the reader to change their tab number to the number of spaces you're using. And that adds more cost and consumes time and energy that you can avoid. Obviously, logical spacing, things, and I don't want to get into too many details. Expressive and clear naming. So, when I'm coding, I'm always going back and changing the names of things. Always. There's almost always a better name. And the names, if you pick good names, then you don't have to write comments. And comments are, some programmers do not write comments, or the absolute minimum. That's my style. I keep comments to an absolute minimum. And the thing is, when you change your program and you change your code, you got to go through and change your comments too. How many times you see a comment that's a comment that was created for old code and you were in a hurry at work? If David's nodding his head back here, you know what I'm talking about. A bad comment is worse than no comment. Now, if you don't have the time and energy and discipline to maintain your comments as you change your code, don't put the comment in there. It makes it a lot worse to read. Instead of putting in a lot of comments that are going to get outdated and disconnected from reality, instead of that, spend your time picking really good names for your variables or functions or classes. Then it's self-documenting. Yeah.
Yeah, I have a friend that after he graduated, he got a job, and they specifically told him your code should be clear enough that you don't need comments, or else you don't belong here.
Yeah, there it is. Well, that's it. That's reality. That's not what you hear in school. Well, this is school, and you're hearing it today for the first time in the universe. But yeah, I know David does a lot of work at the bank. He's a big programmer now. He's got a lot of years' experience, so he knows what I'm talking about. Yeah. There's reality, and then there's what you hear in school. Clear responsibilities. This is a tricky one, when you create a function or a class, it's not always possible in the moment that you're doing it, but if you can narrow its scope of responsibility and make it sharp and clear by the name of the function or the name of the class. And don't resist the temptation to put other stuff in there. And keep the purpose of that function, crystal clear and focused. Don't wander off and do other things. Here's the example. This is a function, is prime. What does that sound like? Is prime returns true or false, right? Is n prime or is n not prime? True or false? That's it. Okay, but look, what are we doing in there? We're printing n to the console. What do we? No, it is prime. It should say, print if prime. So I got to change the function. If prime, then print. But no, this doesn't belong in there. The function is crystal clear. I want to know if n is prime or not. Return true or false. Don't go into side effects. Someone else can print n if n is prime. So don't do it here. That's an example of this criterion down here, clear responsibility. So that function has a clear responsibility. Determine if n is prime or not. To printing it, then it starts getting fuzzy. Unnecessary comments, we talked about that already. Spelling. I'm a bad speller, this is hard for me to do, but that's important. So that's that lesson. And then there's phaser examples. Let's get into here. Got a few minutes here. So let's look at the phaser website. Let me see. These are the phaser examples. Version 2.3.0.
And they just updated, I think, a couple weeks ago.
Yeah, very recently, yeah. And I just started to work with the new one here, which I haven't noticed any difference. Although the documentation is different.
Yeah, they changed it up. I've been trying to get used to it.
Yeah, I think it's better, but it does take some getting used to. Although I tried finding documentation on one of their classes, and I couldn't get to it using their documentation, so I had to use Google to find it. So there's still some weaknesses in there. So there's this examples tab, and then they have where's the documentation?
Oh, if you go under Learn.
Oh, it's in Learn.
Yeah, and then if you scroll down, there's documentation and search documentation.
Yeah, there it is.
I like using search documentation because you can start typing in something, and then it pulls up a list of everything that collates with what you're looking for.
That's what I should have done instead of Google. I should have done search documentation.
Yeah. So if you use search documentation, you can type in input, game.input, and then check for see if you can find mouse pointers and stuff like that.
We'll just try that.
See, and then it gives you that list, so you can scroll down all the method chains and see what there is. Oh wow.
Yeah.
That's pretty slick.
And these are all comments from their source code. I think all their documentation is generated out of their source code comments.
What was really nice is I was actually able to find a couple method chains that helps for some of these examples that you have to do.
What are they called? Method chains?
Yeah, at the top left it says method chains. Right under the search bar, above where all the
here.
Right there says method chains. I guess that's what they call them.
Method chains. All right, so that's the documentation, and then there's examples. And I don't know, just pick this one. Change frame. And these are very simple. They have a lot of these. So here is a, what does it do? Oh, I click there and it just moved it. And this is the document, this is the code right here.
Oh, it changes the frame.
When
you click?
Yeah. It just changed the frame on click, right? That's one frame. I'm going to go to the next frame by clicking.
Yeah.
That's it. Okay. That's it. How do you do that? Now, this is how you do it. And then they have they make these really small, so these examples are tiny. That's it right there.
I think they try and keep them simple just to kind of get to the point on some of them.
Yeah.
Because some of them you don't need a lot of code. You just kind of need enough to get the method to work.
Here it is right there. It's the line right there. Game.input.onDown add. So This is the name of a function. That's the on down, on click handler. And so when the mouse goes down, call change frame. Here's change frame. Change frame. We have this green jellyfish sprite, which they use that for a game object. And we're going to change its current frame by specifying a different frame name. All right, green jellyfish 0010. So then you have to look back here, look, they're loading some kind of an atlas. And where is this green jellyfish? Oh, here it is, green jellyfish. And we do game.add sprite. Anyway, I don't want to get into the details, but that's how we look at these examples. And they have completely reorganized this, by the way. It's totally different. Now, this is how I get it. You can get Phaser by downloading it, but they update it frequently. So I like to clone it from GitHub and then update that. So basically, you just run this command to get the Phaser library. Let's play with this a little bit. We're going to clone the library. And of course, you can find it on GitHub. That's what it looks like. And all the documentation that we're looking at with the examples, all the example code is in here. I'll be looking at source. Maybe it's not under source.
On your website, you have us.
Oh, it's a separate.
It's a separate one.
It's a separate repository. So here's the Phaser repository. But actually, I just showed that to you in temp, and what I do is I have a directory here called Phaser, and I have the Phaser library and the Phaser examples. These are two repositories. And when I sit to work, I usually go to this Phaser repository, and then I pull to get the most recent version. Look at this, see? I just used this the other day. And we just got a, is there a change? No, it's up to date. Same with the Phaser examples. Although I think they changed these a lot. So there's some changes to the Phaser examples. And inside Phaser, you'll see there's that build folder. And there's the Phaser library unminified. This is the minified version here. But what I started doing, instead of getting the Phaser library this way, I changed my approach. There's now a Phaser available through a CDN, Content Distribution Network. Maybe it's on the download link here. Not there.
Dr. Turner, have you ever tested their Sandbox yet?
I didn't.
The Phaser Sandbox?
I did not. Do you know how to do it?
I haven't. I've tried it, but the problem is I don't know how you can use images on there, like to set up the sprites or anything. But what's nice about it is you can actually start typing out code and it helps you finish the chain, so you can kind of go sort through it. It's kind of a good way, I think, to test certain things out.
I tried it. I looked at it, but I couldn't get anywhere with it.
Yeah.
So this is the Phaser Sandbox. Yeah, I tried doing that. I went in here and somehow I couldn't get it to do much. I couldn't quite grasp what it was doing here. So it breaks this out. This is like your functions on the game object. I want to come back to here. Yeah, if we can get that figured out, I'd like to learn how to do that. If you can get that working, show it to me.
Okay.
Where is the CDN link? Is it in here somewhere? It's in there somewhere, but all right. So this is how you get the examples. Now, Chris, so you're running Node?
Yes.
Yeah. All right. So, you can't just open up your project from the file system directly because of some security restrictions. The browsers are nervous when they open up files from your local file system. So they add some extra restrictions there. So most of the time you have to go through a web server that you're running locally. So I use Node, and here's the web server that I'm using right now. That's the code right there. That's how you implement a web server. Let's see, I think I have that in here. All right, so, let me start from scratch. I'll call myself Sam. Here we go. And then we have a program called server.js or whatever you want to call it. And this is JavaScript, and it uses an execution environment called Node, which is server-side JavaScript. So, normally JavaScript runs in the browser. But there's a very nice execution environment for JavaScript that runs on servers called Node, Node.js. And I've been teaching that in my other classes. It's attractive language for web developers because they all have to learn JavaScript anyway. So you don't have to learn a new language. If you start coding on the server side, you can use JavaScript using Node. And Node is very efficient, by the way. You would think, oh, it must be very slow. Turns out Node is one of the fastest web server environments you can have. Go is I think, a little faster. And PHP is slower.
Why is JavaScript so quick? Just because someone else has made advancements in the engine? Or?
I think it mostly has to do with the threading mechanism. One of the important things to remember about JavaScript is it's single-threaded. So your code is only one line of code can be running at any time. There's only one thread. All your code runs in one thread. So in web servers, that's okay because most of the waiting that's done in web servers is blocked on I/O. So you're trying to access a database, that takes forever, right? Or you're trying to write or read from a file, that just takes forever. You're not doing long scientific calculations. That's something that runs in the CPU. That might tie up a thread. But in a normal web server, the stuff that you do in the CPU is very small. And the bottleneck is in the I/O, usually hitting a database or hitting other web services. If you're interacting with Facebook, you've got to hit their Facebook web servers and do some kind of third-party authentication. So it's a lot of waiting around. And so the standard approach is that you create a lot of threads. So your web server is running with lots of threads, and when a request comes in, you got to handle the request. That request is allocated to a thread, and the thread starts processing the request, and it says, "Oh, I got to hit the database now," and so then it makes a blocking call, and that thread goes to sleep. So now it's the problem of, well, how many threads are we going to need, And then you have to sort of optimize on the number of threads you have, and it adds some complication in there. Also, if you've got threads that need to access shared data, then you need to have some kind of a mechanism to avoid, the corruption of data, right? So you need to use semaphores and things like that. So with JavaScript, there's only one thread, so there's no reason to have a semaphore. And you don't have to worry about, creating threads, how many threads you want, and all that, because it's all single-threaded. So in JavaScript, there's no blocking calls. When you want to hit the database, or let's suppose you want to open a file, that's a simpler example. When you go to open a file, Like in C, you're going to say open file. Give it a command open file. And so you call a function. And when the file is open, the function returns a file handle, a millennia later, in CPU time. So that's called a blocking call. So in JavaScript, what you do is you say open the file, and the function returns immediately. Oh, came back right away. But you don't have the file handle yet. So the file handle is going to come later. So what you do is when you call that open file function, you pass in a callback function. You give a name of one of your functions that's going to get the file handle when it's ready. So when you say open file, and you give the name of the file, and you give your callback function, and then the function returns immediately. You say, well, I don't have the file yet, so I'll do something else. And if there's nothing to do, I'll just return. And then later, when the underlying system gets the file open and has the file handle, it then calls your callback function. And then when your callback function runs, I got the file handle. Now I can carry on. So when your callback function runs, no other piece of your program is running. You are the only thing running. So that's why it's single-threaded. So you never have to worry about, I don't want to overwrite someone else's data. You still have to think about those issues, by the way, but it simplifies the problem of multi-threaded code. So that's why a lot of developers like Node.js, because of the simplicity of working with lots of concurrent activities. But it's more complicated because you're writing things with callbacks. When you call a function, you don't say open file, temp.txt. You don't do it's that simple, right? And then it returns the value, but things don't work that way anymore. Now I have to instead of getting a return value, I got to pass in a callback, and it's the callback that has the logic that carries out, what I need to do with that file handle. All right, so I'm just getting kind of abstract here. So here's this is the server, and we're not really going to spend time on the server side, so I don't think we have to worry about this. I don't want to get into the details here. I want to focus on client-side JavaScript more. But we're using a library called ST here, and it's for static web server. And here we're configuring ST. So this is the ST constructor function right there. And you pass into the ST constructor function, you pass in a single argument, which is this JavaScript object. And the JavaScript object has some attributes. It has a path attribute. So the path is set to the current working directory. So that means search, when a request comes in for a file, just look in the current working directory for the file. And then the next attribute of this configuration object is the index. Like if a request comes in for / the root resource, then use index.html to service that request. And then the third argument here is to turn off caching, because we're testing, we're in development mode, so we don't want the browser to cache stuff all the time. We want when we make a change, we want to see the results of that change immediately. So this gives us this object here called static. Then we create the function, create the server, we pass in this callback. You see, that's the callback function right there. And that's the main request handler. So when a request comes in from a web browser, that this function is called. And a request object is passed in, a response object is passed in. This is basic web development stuff. So you just pass that to this static object, and it handles it for you. But once again, you don't even have to read that. You don't even have to look at that. But to run it, you have to have Node involved, Node installed. So you can see here, that's my version of Node. And I run Node server like that. But we'll need a file, index.html. There it is, so hi. So now, and by the way, what port was I listening to? I think I'm listening to, Huh? 4,000, yeah. Now, if you're working in the labs, they opened up port 1989. So I trying to start to use that. It's hard to remember, right? But for Chinese, it's easy to remember. What happened in 1989? Anybody know? Yeah, you got it. Yeah. So that's how someone up there remembered it that way.
Berlin Wall.
I think
In 1989, Berlin Wall came down. I didn't know that. That was a big year. So let's look at that high thing. So we go to localhost 4,000. Here's the high. And then, and then what you're going to do is you're going to make changes to that and then test it. Like, oh, okay, well, we made this change to our game. Let's refresh the browser. There it is, bye. Another thing, and we'll look at this maybe later, it's really convenient to, this is not right. It's really convenient to open up in Chrome. And I got to remember how to do this. I thought I got it right. That's not it? How do I?
Are you going to open the developer console?
Shift, Control, Command.
Or right-click and inspect element.
I got it. It's Alt Command on Mac. Alt Command J. I know I could do it through the menu, but I want to keep forgetting those hotkeys. And then now this is called like your web inspector, web tool, and this is very handy. This is Chrome, but you can use this in Firefox. Firefox has got really nice web development stuff, and IE, probably have something, but IE has been lagging these days.
Wait till Spartan.
Huh?
Wait for Spartan.
Yeah.
That's the browser.
So this is your console right there.
Go through a name change, I guess.
Now look at this.
shut off the podcast.
Here's a web page here. So console.log. I'm the log. These days, like that's not much of a web page, just a script element. But I believe that will function. Watch, refresh this thing. I'm the log. See, there's a JavaScript log, so you can write to it using that console object. Now, the thing is that there's a setting here which is really helpful. Disable cache while DevTools is open. It's easy to get tricked because the browser's always trying to cache stuff. And sometimes when you make changes, you won't see the effect because you're looking at something that's in the browser cache. So you've got to always be aware of that. The best, for me, the safest way to go is I leave this DevTools console open and I make sure that thing is checked. And that's it. And then I know that my changes are going to be pretty fresh, when I do a refresh here. So that's that. And I think we're out of time. We're going to resume. We're going to go in the lab, and then I'm going to spend, for the people working on Phaser, I think you should come to lab today. I'm going to run through this and bring your laptops, and you can do this. I want everybody, if you haven't gotten this far yet, you get things set up and running, we can do some of the exercises together in lab today and save a lot of time, okay? All right. So we'll see you upstairs. I'll be there at 1:30.